All right, so I got a couple scrap items I want to disassemble and see what is inside these guys. The first one's going to be a Automation Direct Rhino. That is a 24 volt at 20 amp DC power supply. Now this thing runs, we use 3-phase 480 volts in my work. And so this came out of one of my packaging machines that failed. And it just went dead. It does not output any voltage. The DC OK light is not on any longer. I didn't replace it. One of my coworkers did, and he left it laying in the shop. And I'm like, I'm going to scrap request this thing and tear it apart, as well as check out this contactor, little tiny thing. It's only rated at 85 amps, I do believe. Well, according to this, it's 100. But I was told it was an 85 amp contactor. And then there's the KW ratings at various voltages. 100 amp enclosure. Horsepower 1-phase 7.5, horsepower 3-phase. And we use 460 volts, so 60 horsepower. SC rating, C instructions. Break all lines. So this does not have an auxiliary contact. There's the spot where you would attach the auxiliary contact on each side of it to do what you need to do. For some reason, I thought this was 85 amp rated. It's 100. Definitely a IEC contactor and not a NEMA. If it were a NEMA, it would be probably bigger than that. I don't know, size 2 or size 3. But let's go ahead and we'll get this one out of the way. And I just want to open this thing up and see what is inside it. I wonder, will it come apart peacefully, or is it going to want to fight? It's going to pop these 4 screws out, and then maybe we can just pop the cover off of it. Both of these, incidentally, were DIN rail mounted, as you can see right there. Anyhow, look at that. Might not. I thought it was... Oh, still maybe. Oh, yes, it will actually open up. Oh, incidentally, there is the model. And there we do have the top off. Model PSB 24-480S3. Input 3-phase 400 to 500 volts, 1 amp. Output 24 volts, 20 amps. And there is the inside view. Let me go ahead and pause this and pump up the exposure. One moment. Okay, that looks just a tad better to me at least. Hopefully it's not too over bright. So it looks like I could just pop a bunch of screws out of this thing. And we'll just pop it open and see what lives inside. That's a self-tapper. Who would use a self-tapper in an industrial application? Looks like here's some coupling screws that couple. Hopefully it's not charged. I don't think it is. It's been off for at least a week. And another screw over here. And another screw over here. And yet another screw over here. Whoops. Okay, that might be most of them. And it appears that it is, because the board is beginning to move freely. There's a connector here. Hopefully it will maybe unplug without too much effort. Appears to have some Celastic on it. We'll just give it a little bit of help. And if it breaks, it breaks. No, it did not break. Look at that. Okay, so there's a tab over here, so the board's got to come up and out that way. And then there is the main switching supply. Oh, look at that. Actually put a cover over the bottom of the board. Well, we'll go ahead and zip that off real quick. because I want to check these 3 fuses right here and see if any of those guys might possibly be bad. 3.15 amp, 500 volt rated fuses. Yeah, I could probably get them from the top of the board, but let's just take a look at the bottom. One moment. Well, it certainly looks like it was a mistake to take off the bottom because this whole board is coated, as it should be for moisture intrusion. Looks really good though. But yeah, there's the full wave bridge rectifier for 3 phases right there. And then it looks like it follows a line up and goes to one of these terminals over here. Possibly, I'm not sure. But I think I can probably get on the fuses from here and just see if we got possibly a blown fuse. Get a voltmeter set up in the beeper mode. And we'll just start here. Oh, it's coated too. That side's not, but that side is. And it appears that fuse might be blown because I think I have dug through the coating. Yeah, I'd say that one is blown. That one is good. And I'm going to say that one, I'm pretty sure I'm on the connection, is blown as well. So we got 2 blown AC input fuses. So do we have shorted diodes over here? We'll have to dig through the insulation and see what we get here. So, okay. So these are common. And so I'm going to say these are common as well. Well, to 1 phase, 2 phase, and 3 phases. Okay, let's just check the diodes. Not shorted, not shorted, and not shorted. I should put it in the diode mode. That would be something. 516, 516, and 517. Now, are these common? I don't think so. I bet it's going to be these are common down here. Yep. So, we'll go from here. 516, 516, and 516. So those diodes are all good. No shorts there. So definitely we know we blew 2 fuses. And it doesn't look like the metal oxide varistors have exploded. I think that's what those guys are, possibly. There's only 2 of them, though. I expect 4, actually. Some thermistors right in here, NTC 1, 2, and 3. Might save those and put them in the thermistor drawer. Looks like fairly good quality caps. 1500 at 35 volts. I'm sure these guys have got to be 105. And yes, they are 105 Celsius caps. Not bulged though. So next I'm going to go ahead and zip this apart and see if we can find probably a shorted FET over here on the converter, maybe on this side over here. But let's get this off of the chassis and we'll be right back. One moment. Okay, so I've certainly got it torn apart, and take a look at that. I must commend them for that use of the regular stand-up capacitor leaded electrolytic on a small circuit board like that. Everyone else would have gone with a surface mount. Rubicon 130 Celsius capacitors right there. That's probably an 85 down there. And look at the work they went to with the tape on these guys, and then heat shrink over the outside, it looks like. Wow. Way to go the extra mile. And then there's the coating right there on the bottom of the board. So it looks like they might have dunked it. I'm not sure. Quite possibly, but there's probably 4 FETs there possibly. But I'm concerned about these guys right there. No, those are the diodes right there. Huh, okay. Well, we have it in the diode mode. Let's see if they test like diodes. I should move this over so you guys can see it. There you go. So that one is definitely charging. And we'll go backwards, it'll discharge. And I bet these are shot keys with like a 0.15, 0.2. There we go, 0.211. And 0.211 on that one as well. Those are fine. Those are the rectifier diodes. Here's a big switching FET right here. And look at that, a short. And a short. Let's go to ohms and see how shorted it actually is. Oh yeah, 0.1 ohms, great. And 2.7 ohms, that thing is toast. I'm surprised that we don't see any burned up components right here, like especially in the gate drive or some of these little resistors. Maybe they are, let me zoom in on it, one moment. Okay, well there is the FET, those 3 leads right there. And it definitely goes through a little resistor and a diode, a couple of other diodes, a R250 right there, 2R21, 4R75. I don't see anything blown up at all, but we know for sure that that FET right there is shorted. Let's take a look at the other side of the board. Let me zoom out one moment. Okay, so taking a look at this side of the board, I'm pretty convinced that those filter caps might have something to do with the B plus coming through right there. Possibly not. It's weird though. Yeah, it comes right through. So this must be where the high voltage were to come in right there. And it looks like it goes through an inductor. Oh yeah, and it then charges the 2 big beefy filter caps right there. So I'm curious, do we have a short right here? So let's get the ohm meter in view. Make sure we're in the ohm range. And I'm betting that we do. Yeah, 0.4 ohms. That's that shorted FET down there. So we checked the, it's that shorted FET right there. So we certainly did check the output diodes over here, heatsink compound everywhere. And so this must be the 24 volt output. Let's see if we have a short on that line. And we are charging in that direction. And it should discharge. Well, we'll short it out to discharge it. And it should charge up in that direction as well. And it does, 620 ohms. Perfectly fine with that. So I think I do see a cap buried down in there. I'm not going to pull it out, but it wouldn't surprise me if one of these little caps got baked in this thing. I do believe this has been in service for probably 3 years, if I had to guess. And I'm just wondering if, well, way overexposed. One moment. Let's back that down. There, might have a chance of seeing that. I wonder if there was a date on this that we could decipher, possibly with the serial number. 2009, no, it's way newer than that. And I don't see any other date codes on this thing. Made in Thailand, so that's good. Anyhow, let's get to the contactor. Push that guy aside. And push that guy aside. All right, let me correct the exposure. We should go to auto magical and then we'll pump it up just a little bit because it's primarily white. So this contactor stopped working in one of our machines at my job. And I thought, well, what's wrong with it? And one thing I know is wrong with it because I troubleshot the machine. It takes 120 volts on the contacts right here, which is the coil. And as you can see, it is absolutely open. Open, open, open. Put my fingers against it and we should get, yeah, so we get meg ohmage just with my fingers touching. I suspect the coil burned up. So I want to go ahead and pop this thing open. It looks like I do need a flat screwdriver. Really? Oh, okay. Let me find one. I hardly ever use one. One moment. Okay, so yeah, either a Torx or a flat screwdriver right there. And then another one on that side. It should separate the two halves. Sometimes on the smaller Allen Bradley contactors, there's a spring clip you got to unclip, like up in here, and another one down here. But this one may, ooh, and it does. It just comes apart. So there is the coil. And since the coil is open, I'm pretty sure, yeah, baked. I'm pretty sure we're going to find a burned up coil and maybe even an open lead somewhere. Oh, look at that. Very crusty right there. And oh, there's a problem right there. Bluetooth connection. That's what's going on. It burned up the coil. I wonder if we can get the contacts out. On some of these, you can pull the contacts out. So that's what you hear when it pulls in. And then a little extra spring pressure. Let me see if I can get the top off of this thing and we'll take a look at the contacts. One moment. All right, so how do these contacts come out? Now I know on some of these you can just, once you get the contacts out of the way, you can pull the, well, the lugs out of the way, you can pull the contacts out. This one does not appear to be that way. I wonder if I take the arc shields out, if I can. Oh, yes, I can. These should actually just pull out. Let me try to give it a little extra force. And no, oh, look at that. It's got screws holding it down, but I have to disassemble the magnetic portion to get this part out. Unless they put the contacts in. Sometimes you can tip these guys sideways. Let's see. End up damaging the contacts, but maybe. Try a different pair of pliers. Okay, well, I got one set of contacts out. They don't look too terribly bad. Boing! Hey, found it. Look at that. That's 1 in a million. The spring would come back. Okay, so now I can get the other half of the laminated magnet out of the way. I don't think we have to take it much farther apart than this, but the contacts actually look pretty doggone good. I think this runs a Allen Bradley Kinetics servo drive pack. It's got like 6 motors connected to it, but I don't see any issues, at least with the contacts on this. I think it was just the coil that gave up the ghost on this guy. And it is a few years old. Look at the date on that. I think it's possibly 2013 if I had to guess. 12/17 of 2013. That seems about right. This thing's about 12 years old, so that would make perfect sense. Anyhow, look at that. You could probably use those as nice little heat sinks. Copper coated zinc if I had to guess. Have to drill a hole and mount a little transistor to them, and they'd probably do a very adequate job. I'll probably save those. Who knows? Anyhow, that's it. The Allen Bradley, and where was the model number? Somewhere. There it is. The 100-C85 asterisk 00 Series A. And a look at the Automation Direct PSB 24-480S3. What was this? The Rhino 20 amp 24 volt power supply. Okay, everyone, thanks for watching. Hopefully somebody enjoyed this. Not quite sure who, but might harvest a couple of parts off of these boards and just save them for a rainy day. Everyone, have a great day. Bye-bye. And I thought to myself, pull one of those caps out. Just take a look at it and see what they are. So I went ahead and I pulled it out. I sliced the heat shrink off of it. Pretty good quality. Removed the Kapton tape they had wrapped around it right there. Look at that little insulating layer on the bottom of the cap. That was me, all me. So I thought I would get the ESR meter out. And we'll zero it out. And so this is a Rubicon 270 at 450. I'd expect to see probably about a quarter ohm. Maybe half an ohm. And I see 0.19, 0.20. And why are you not focused? And on the other one, I see 0.24. So, was not a main cap failure. Once again, thanks for watching. Have a great day. Bye-bye. Okay, well, I've got it torn apart, and I must commend them. Look at that, a surface mount capacitor on a stand-up board. I would have, or sorry. Okay, let's take that again. Okay, zoomed out, so flipping this thing over, I'm just curious. I think this is the, I think that is, let's start that over. All right, there we go. Check, check, check.